Assalamualaikum everyone. Today we're going to cover the second part of designing IoT system. We're going to cover the next four parts of the designing IoT system, which are modern communication protocol, wireless communication technologies, proximity network communication protocols, and also gateway. Let's see the modern communication protocol first. Although we know that internet communications using the Zigbee, using the Wi-Fi, and other wireless communications is important, apart from that, Ethernet also is very important in the IoT systems. Okay, so what is Ethernet? Ethernet is a system for connecting a number of computer systems to form a local area network, so that the protocol can control the passing of the information and to avoid simultaneous transmission by two or more systems. Okay, so although the what we call the wireless type of network is important, but this kind of connection between the computer system and everything is still required in the IoT system. So we need to know two types of the Ethernet. The first one is the standard Ethernet. So I believe everyone already familiar with the Ethernet. In our what we call in the university, in the building, usually we use this Ethernet to connect between the computer and also the internet. So for example, one of the example is the LAN. When we are using the internet, LAN internet, so we're using the cabling for with the Ethernet. Okay, so this one is already accepted everywhere in the commercial enterprise and everywhere. Okay, so Ethernet is not only a protocol, it is also a technology. Okay, so it's transported over copper wire, which is known as Cat5 and 6 cable, optical fiber, and also radio wave also being used in short, middle, and long range deployment. Okay, so Ethernet is popular because back in 1980 it became dominant network technology in everywhere is using this type of connection between the computers, the devices, and everything. Uh, it's also cheap and easy for the designer to plan the network topology for all the what we call the devices that they have. Okay. um, Consequently, Ethernet became the well-established network technology in the enterprise, and today we are unlikely to come across anything else in commercial and business computer networks other than Ethernet. Okay, so apart from that, Ethernet also keep moving forward. Okay, so they are improving the what we call the type of cables that being used. For example, from the copper wire to the currently the fiber wire, right? So we can see that they are improving the facility, the physical things, in order to make that particular connection is much more stable, much faster, and it can cater a lot of environment also. That's why it is a well-known system or protocol that being accepted everywhere. Second one is industrial Ethernet. So industrial Ethernet is not much different from the Ethernet we use in the business. Okay, so it is not much different, except that the cabling and also the connection is much more robust. Okay, so this one is to cater with the what we call the environment in the industry itself, where it can be severe. Okay, so the industrial internet is 100% interoperable with standard internet, so meaning that you can work together because the system and the protocol is the same, only that the physical thing is quite different. Okay, so industrial internet use robust cabling, is much typically endure the harsh environment with the high temperature, greater level of vibration, interference, and also the humidity. Here is the link for the industrial and standard Ethernet. You can read through this information for much more understanding of the topic. Now let us go to the next topic, which is the wireless communication technologies. As we have seen in the previous part of the lecture, we know that Ethernet is very important in the connection between the computers and devices. However, wireless connection has made the Internet of Things possible. Previously, the problem with the what we call with the factories, which is there is no way that we can connect the sleek microprocessor and controller to the sensors and also the actuator without running the wires throughout the factory. In this matter, wireless communication technologies such as Wi-Fi, Bluetooth, and Zigbee has removed this large barrier to entry, and now so that we can connect the devices to the microprocessor. However, this is a recurring theme. There is not one wireless standard that will fit all the purpose in the factory. We need variety of type of wireless communication, and even each type of this type of wireless communication might have some problem also when we when we install it in the factory. Okay, so the array of wireless technology has arisen because they serve different purposes. In previous classes, we already see a lot of wireless connection type. Okay, so but in this lecture, we are going to focus on the three most used wireless connection that being used in the factory. Okay, so among them are Wi-Fi, Bluetooth, and also Zigbee. Okay, so as we know, Wi-Fi is designed for high bandwidth, so the throughput for web browsing and downloading from internet will be very fast, and it will be better. Okay, so for the Bluetooth, it is designed to provide a personal area network to connect wireless devices, so that you can wear and carry. And for example, if you have a certain machine or certain sensors that connected to the Bluetooth, so when it enter into that range, it will be used according to that area of connection only. Once it goes out of that area of connection, then it will be what we call it will not be detected. It will be what we call be separated from the main part of that Bluetooth area. Okay, so in order to what we call to expand that usage of the Bluetooth inside the factory, they also increase the Bluetooth range into the beyond that PAN personal area network only. Currently, it's using the what we call smart Bluetooth that we are going to look into after this. Okay, where it expands the area and also they add a little bit more of capability, which is Piconet. Okay, so the last one is Zigbee, which is the capability fell somewhere between the Wi-Fi and the Bluetooth, or at least that it has started out. Okay, so not only that it is less stronger than Wi-Fi, but it is stronger than Bluetooth, right? So that Zigbee become in the middle of between Wi-Fi and Bluetooth. Okay, so now Zigbee not only cover on the area in the house, it also has been increased into the neighboring area network. Okay, so that it will become a bigger coverage for the Zigbee. Regardless the technology that we choose to adopt in our factory or in our industry, there will be always constraint. For example, range constraint, throughput, power, physical size, and cost. Okay, so that's why we must diligently approach this according to the needs of our area, according to our industry, according to our use when we want to select which type of the wireless communication that we want to adopt. IEEE 802.15.4 is the technical standard that usually used for the low rate wireless personal area network. Okay, so this the short form is LRW PAN. Okay, so that is the what we call the standard that being set by the IEEE. Okay, so it was first back in 2003 to set the standard for low power commercial radios when RF is start being used in the industry. So the standard was upgraded in 2003, 2006 and 2011 so that it provide more energy efficient radio technology. So IEEE 802.15.4 is basis for the ZigBee, ISA 100.11a, wireless HART and MyWi specification, each of which further extend the standard by developing the upper layer which are not defined in the IEEE 802.15.4. Okay, so alternatively 802.15.4 can be used with the 6 low pan and standard internet protocol to build a wireless embed internet. As I mentioned previously about the Bluetooth, so currently in the industry they have developed a new Bluetooth which is known as Bluetooth Low Energy, which also known as Bluetooth 4.0 or Bluetooth Smart. So this version of Bluetooth technology is specifically designed for the IoT. Okay, so why it is designed for IoT? Because this type of Bluetooth is using less power and very resource friendly, which is designed to run on low power devices and typically run for low periods, either harvesting energy or powered from the coin size battery. Like I mentioned previously, the technology is going into the what we call the device itself can generate or harvest the energy in order to make sure that uh, the device that we use can be used for a long time, and also it can operate on its own and without fail even if the power is very low. The same like the things that we discussed previously about the Bluetooth, the same with the Bluetooth low energy. Of course, this Bluetooth technology is already been here for decades, so the advantage will be billions of Bluetooth devices can be connected using this Bluetooth low energy. It also a well-established and recognized standard wireless protocol, so that's why there will be vast multi-vendor support and interoperability, which make it an ideal technology for the developer. Okay, so why we need to change to other things when the platform is already there? So it will be easier for us to just use this Bluetooth and upgrade it into something that is much more beneficial towards the industry. Apart from that, it is low peak, average, and idle power, which allow the devices to run on low power resources. So make it ideal for low power devices such as WSN nodes and in the IoT on the M2M edge networks. Okay, so the last one is Bluetooth work over a short range, and Bluetooth enabled devices pair with one another in a master slave relationship in order to communicate. So this one, master slave relationship, will make it easier for the what we call the devices to connect to that connection of Bluetooth. Okay, so meaning that there will be one main a Bluetooth operator, and then we can just put in the devices that we want to connect to it as a slave, what we call as the additional part towards that main body that run that Bluetooth. Okay, so then if we don't want to connect it, it's just disconnect when it goes out of the area of the connection. Okay, so then it will be very easy for the connection and the reconnection and also to separate it from the main body. So this advantages is called the system that I've mentioned previously is called Piconnets. Okay, so um, a Piconet is a group of pair Bluetooth device that can form dynamically as device enter or leave the radio proximity, meaning that whenever the parts enter that main the master connection of Bluetooth area, so then automatically that Bluetooth unit which is the slave will be connected to that Bluetooth unit, master Bluetooth unit. Okay, so the Piconet consists of 2 to 8 devices that communicate over short distance. Okay, so of course the area of the connection is bigger right now for the what we call for the industrial use, but we can take example if let's say you already open the Bluetooth on the laptop or your computer, and then you have the mouse, you have the headphones, uh, all of these things is the example of how the connection between the main, which is the master unit, and then also the Bluetooth slave unit when we use it for the personal use. Okay, it's the same for the industry where there will be one master Bluetooth unit. Okay, and then when we approach that part with the sensors or with the actuator that can connect directly to that master unit, when it enter the area according to that that we set. Okay, so we will be able to connect to that master unit directly. Okay, so we already see the Zigbee previously. So you can read on this introduction about the Zigbee again, but I'm going to skip it because it is repeating the same thing that we learned previously in as the Zigbee. The most important thing is we want to see about the Zigbee IP. So we already see the Zigbee in the smart house in the PAN connection for the internet. Okay, so the problem with the original Zigbee standard that used in the house or for the personal use, it did not support IP, which is meaning that it's interconnected between the devices just using the what we call the Zigbee connection itself, which was problematic when it comes if we want to interface the Zigbee network with the real world. Okay, however, the Zigbee IP specification is built with a layer architecture and is therefore suitable for any link layer within the 802.15.4 family. So Zigbee IP take advantage of this layer approach and incorporate technologies, for example, 6 low WPAN and RPL that optimize meshing and IP routing for wireless sensor network. So in another way, we are saying that since Zigbee is using that IEEE 802.15.4 what we call layer architecture in their system, so it is in the same family with the Wi-Fi and also with the what we call this connection, this type of connection. So since they are using the same family, so it is much easier to create it into Zigbee IP so that we can connect this Zigbee towards the IP. Okay, so to make it IP friendly. Next, we look into the proximity network communication protocol. When we want to consider the protocol for the proximity and access network, we have to consider the diversity and capability of the existing devices and the communication lower layer protocol. So usually, as we see previously, the most used network is using the Ethernet. Okay, so when we do the Ethernet connection, of course we will need IP. Okay, so however, as we learned in the previous section also, not all protocol will support IP, so you have to consider this protocol when we want to find the what we call the common data and network layer protocol. So there are two type of internet Inter-Network Protocol, which is IPv4 and IPv6. So let's see the IPv4 first. Okay, so the IPv4 is address is a 22-bit number that uniquely identify the network interface on a machine. So it is like an address to a house. Okay, so this IPv4 address is typically written in decimal digit, meaning it's its number. Okay, so it is formatted as four 8-bit fields that are separated by periods. Okay, so each 8-bit field represent a byte of the IPv4 address. So IPv4 will use 32-bit addresses, which is limit the address into the spaces around 2 with the power of 32 addresses. Okay, so due to this, only around 4 billions number of addresses can be generated by using the IPv4. Okay, so during that time when the IPv4 is created, it is said that this number is enough for the what we call for all the computer. Of course, during that time, not many computer is being used, and not many devices being using the network. Okay, so IPv4 will reserve special address block for private network, which is around 18 million addresses, and then a multicast addresses around 270 million addresses. So we're going to look into what is private network and what is multicast network. Okay, let's see the two type of the network, which is private network and multicast network. Okay, so for the private network, it is used for the private address space of IP addresses. So this one is address that commonly used for the local area network LAN, for residential, for office and enterprise environment. Okay, so this is the most common one that we use daily. Okay, for multicast network, it is a group communication where data transmission is addressed to a group of destination computers simultaneously. So meaning that it is used for the what we call for the multicast, meaning the communication of the destination computer is a lot. Okay, there are many of them. Okay, so it can be one to many or many to many distribution, meaning that it can be from one center part of the network provider towards a lot of computer, or it can be from many points to many computer distribution. Not only a computer, just example is the computer, it can be many devices, other devices also. Okay, so this is usually employed in the IP application for streaming media, for IPTV and multicast video conferencing. In here, I'm showing you the example of the IPv4 address. So if you can see, it is four numbers that divided with the three dots in between here. So if we can see here, the first two part of this number is the network part. Okay, and another two part here is the host part. So what is network part and what is the host part? So network part is the network specify the unique number that is assigned to your network. Okay, so for example, in one university they already have one network system, right? So they already have their own address, which is the network part. Okay, so this number can be the same for the whole what we call the whole topology of the network. Okay, so only the two part at the back here for the host part can be different when we connect different type of computer, different computer and devices to the what we call to the network part. Okay, so the host part is the what we call the of the IPv4 address is you assign to each host. Okay, the host part uniquely identify this machine on your network, and take note that for each host on your network, the network part of the address is the same, but the host part must be different. So as I mentioned, so when we already have let's say for example, in a one university, everyone is using the network part is the same, but when we assign a different computer to it, so it will, the host part will be different for each of the computer. So in here, as I mentioned, I just want to define it again. So a network is a group of two or more hosts that connect using a common protocol language communication. Today, usually we use the Ethernet or Wi-Fi for the protocol, IP protocol. Okay, so for the host, anything that require connecting and communicating with other hosts over the network. It can be computers, it can be network printer, it can be smartphone, tablets, and even TV and fridges also. So let's see how the IPv4 address will look like and how it is addressed in the dotted decimal notation. So if you can see the number here, there are four number that are separated by the dot. Okay, so each of these number represent 8 bits. So if we want to translate 172 in a bits number, which is 10, so it will be like this one. Okay, so this one will be counted as 8 bit, and then another 8 bit for the 16, and then 254 is another 8 bit, and one number is another 8 bits. Okay, so when we combine all together, it becomes 32 bits or 4 bytes of address. Okay, so that's how the IPv4 address is read. Now, IPv6 is the latest version for the Internet Protocol, which identify the device across the Internet so they can be located. So, as mentioned previously in the class, every device and every what we call every computers that connected to the network will have their own specific address, right? So they need to have their own IP address so that it can be communicated. So we don't want, let's say, to send certain information to the wrong address, right? So that's why it is very important to have a correct IP number. Okay, so that the information to each of the computer or to each device is what we call can be delivered correctly. Okay, so for the difference between IPv4 and IPv6 is IPv6 is using alphanumerical notation when it's creating the address, okay, compared to the IPv4, which only use the number. Okay, so this IPv6 is already created around nearly 25 years ago in 1998. It is created instead of using the 32 bits of address, is using 128 bit addressing in order to support the increasing number of the address. Okay, so it can goes up to 340 trillion address for us to use. So if you want to define it properly, so IPv6 is the Internet Protocol version 6 address, or simplified into IPv6 address. It's a numeric label that is used to identify and locate a network interface of computer or a network node participating in the computer networking using IPv6. Okay, so as I mentioned, it is using the 128 bits address, alphanumerical, while it is different from the IPv4, which only use the 32 bits numbering notations. Okay, so let's see the IPv6 address, how they write the IPv6 address. Okay, so if you can see here, they will have 8 what we call numbers, alphanumerical numbers combination over here. So the first 3 is assigned under the prefix, and then 1 for the subnet ID, and the last 4 is the interface ID. Okay, so let's see what is site prefix, subnet ID, and also interface ID. Okay, so site prefix is what we call contain the site prefix, which is describe the public topology that is usually allocated to your site by a ISP or regional internet registry. So if we want to um, what we call make it similar to the normal address that we want to look into, to make it is to simplify, to make you understand, if we can see our home address will be the home number, and then we have the route number, and then we have the regional, right? So this site prefix is the regional area, let's say for is Gombak or something like that. Okay, so and then subnet ID is where which you or other administrator allocate for your site. For example, for us, it is for the private topology, which is the site topology. Okay, so for example, this is Gombak, and this is IUM area. Okay, and then interface ID is the rightmost four field contain the interface ID, also refer to the token. So this one is the specific address for the numbering of the devices that connect to this network. Okay, so usually this is automatically configured from the interface of MAC address, or manually configured using the EUI 64 format. Okay. So here I put an example for all of you to look into. Okay, so this is the example of the IPv6 address. So for this one, the first three is the site prefix. So you will see that this is represent the public topology, and then this is the subnet ID, which is containing the private topology for the site, and then the interface ID, which is the one that connected to the all the devices that connected to the this network. Okay, so let's see the difference between the IPv4 and IPv6. So the first one is, as we know, IPv4 is the earliest what we call version of the IP. It is deployed in 1981, while IPv6 is deployed in 1998. And then in terms of the addresses, IPv4 is using 32-bit IP, while IPv6 is using 128-bit IP address. Okay, so if we calculate, IPv4 is capable to generate 4.3 billion addresses, while IPv6 capable to be what we call to get the address is 7.9 times 10 power of 28 addresses. Okay, so as for the IPv4, since it is not enough with the 4.3 billion addresses, so if we want to the address, we have to reuse and mask the previous one, the used one previously. Okay, so as for the IPv6, every device will be able to have their unique addresses because of the large number of the address. Okay, for IPv4, they are using numerical dot decimal notation. If you can see all the numbers, okay, so numbers with the dot in between, while the IPv6 is using the alphanumerical hexadecimal notation, where the alphabet and also the number is what we call added together inside the address. Okay, so for IPv4, it's using DHCP or manual configuration but for IPv6 it support the auto configurations. Here's a link to the video also regarded to the IPv4 and IPv6. Please look into the video so that you can understand more. The last part that we're going to look today is the gateway. So let's see what is gateway. So gateway is a network nodes used in telecommunication which connect two networks with different transmission protocol. We will see the example in the next slide. Okay, so gateway serves as the entry and exit point for the network, as all data must pass through this communication with the gateway prior to the being routed. So meaning that all of the data will go through the gateway first before it goes into the what we call into the storage, into the analysis area, into the internet. Okay. Now let us look into the example of gateway in the IoT. Okay, so for example, in the factory there might be thousands of sensors being used, and also the actuator. And this sensor and actuator might be using what we call different type of communication protocols. Okay, so in order to make sure that the information that transmitted to the data center is standardized, gateway will be placed in between this, okay, where all the data will be translated into one what we call language that can be accepted and can be easily analyzed in the data center is infrastructure. So this is the purpose of the gateway. It will sort out, it will transform the data that need to be what we call into something that readable into the data center infrastructure. Okay, so that will there will be less time for the data to be to be what we call in organized. If not, then when all the data coming in form of a different protocol into the data center, it will be very difficult to be sorted, to be analyzed. Okay, so that's why the gateway will play the role of sorting and eliminating all the data that is not reliable or not redundant or something like that from the during this area at this area. Okay, so before that then after that the data will be analyzed and goes into the IT apps or something that visible to the consumer, to the people to be used. Okay, so that's the purpose of the gateway. So from the example, we can say that the gateway will allow us to integrate the diverse technology and protocol into the common network. So this is very important when we want to build the interconnecting network. Okay, so that gateway play a very a huge what we call responsibility, where it allow us not to restrict to IP in order to connect between the devices and also the data center. By having the gateway will be able to get all the information from the sensors, from the actuators, and gather all the information. And through wire it can be done through wireless connection. Okay, so this gateway then we can transfer is the data towards the data center. Okay. Thank you very much. So I hope you will be able to understand everything. If you have any question or anything related to this video, you can ask during our next class. Okay. Thank you very much. Assalamualaikum.